Hi, I'm Don from WEST SYSTEM Epoxy. Today I'm going to talk about repairing a machine hole. We had a sink that was installed in here that would drain out through this Thru-Hull here. We're no longer going to use a sink, so I'm going to do a fiberglass repair to seal it up and make it watertight. We used a chisel to remove the sealant from the outside, so now I can take my tape measure and measure the overall thickness of the laminate. The thickness of the fiberglass laminate is very critical to determine the bevel angle and the amount of fiberglass layers that are needed. So we have a solid laminate here. I'm going to measure the thickness. Looks like it's 3/8 of an inch. So what I do is take 3/8 multiplied by 12. It's 4.5 inches. So that means from the edge of this hole here, I need to measure out 4.5 inches, and that's the length of the bevel angle for this repair. Seeing that I do have access to the inside of the hull here, I do want to do all my grinding and beveling to the inside here, and the reason for it is on the outside there's a style line, and I do want to minimize the overall gel coat repair. So now that I'm ready to measure my 4.5 inches, I have a Sharpie here and I'm going to measure the outline, so now I know how far to grind out to. So now we're ready to grind. There's a couple things I want to show and things to consider. I got my grinder here. I got a flappy disc on here. If you get like 40 or 60 grit aluminum oxide paper, that's going to be fairly aggressive and that's going to remove a lot of material fairly quickly. I always find it helpful to change these out when you find that they're not cutting clean. It's easy to replace fairly quickly. So when I'm using my grinder, get it over here. You want to always have two hands on the grinder, and you want to keep it away from you. So as I grind, what I'm going to do is I'm going to start to the inside and grind that down, and like I mentioned earlier, I want to try to get it to a feathered edge. So I want to grind down a lot here and work it out to the outside edge where it's going to be full thickness. And as I grind, you want to make sure that you're not dishing the area out, you're keeping it in a flat plane. So I have a mixing stick, which is a nice straight edge here. I can actually put it on here and make sure that I'm keeping a nice flat plane to the area that I'm grinding. So I have my full face mask, which is going to be helpful so I don't have to have safety glasses on or a mask. So that's what I'm going to wear. As you see in here, I got plastic in here. As I grind, it's going to be a lot of dust. Debris coming off the grinder, so I have a vacuum here. I'm going to pick up a lot of that from the air. Just do what I can to stay as clean as possible. So that's why I got a platform in here. It makes me stable, so when I use the grinder, I'm not worried that I'm going to lose control of it as I'm grinding. So we'll get started here and get this all ground out, so get it ready for some fiberglass cloth. So one thing that I want to show before I get it all ground out, your hands will pick up a lot of imperfections to see how fair it is. Just running your hand over the surface will pick up like highs and lows. In the area back here, it's a little high. That means I'm going to have to get back on it with the grinder to flatten it out. Then I can take my mixing stick, get it on the surface, and I can get a good idea visually to see if I need to grind more. So it really works well to keep the grinder as flat as possible and keep it moving, working to kind of get it as much down to the inside of the area that mainly has to be removed, and then work to the outside. So I'm kind of going a little bit more aggressive to the inside than working outside to the outer edge. So I'll get my mask back on and we'll continue to grind. So now that I have it ground fairly close, you can run my hand over it. I do feel a little highs, kind of waviness. So what I'm going to do now is I'm going to switch my tool out. Instead of using my grinder, now I'm going to use an orbital sander. This is actually going to create a nice flat surface. This will create good surface profile too for me. So I'm going to get on here and just work the sander around the outside edge, and that will help flatten out my bevel angle. So what I want to do now is I actually want to switch back to my grinder, because right around the hole, it's right around about 1/8 of an inch still, so my grinder is going to remove the laminate a lot faster than the orbital sander. And then there's a couple little high spots that I'll knock down quickly. Then what I want to do is switch over to about 60 or 80 grit aluminum oxide sandpaper that I'll come in and I'll hand sand, and that will provide good surface profile for the epoxy to adhere to. So what I'm doing now is just a final check with my mixing stick to just make sure that the area is nice and flat, it's not dished out, and that there's not any high spots. So I just will go around the edge. So from what I can see, it looks like it's good. Now I can go right into my hand sanding part of it. So take my sandpaper. So now I'll vacuum up my sanding dust, and I'll be ready to apply the fiberglass once I determine how many layers I'm going to need. So now that we have the grinding complete, we need to determine how many layers of fiberglass. That goes by the overall thickness of the laminate and the weight of the fiberglass cloth. Now that I know it's 3/8 of an inch because I measured it, I want to use our 738 biaxial fabric that has match stitch to the back. It's approximately 24 ounces per square yard. If I reference our WEST System product guide, in there's a chart that gives an average single layer thickness per each of our fabrics that we offer. And with our 738 fabric, one layer wet out by hand is 0.039 inches. Now that I have the area beveled and we're ready for the fiberglass cloth, I want to make sure I don't create stress concentration on the outside edge of the fiberglass. I want to make sure each layer is consecutively smaller so it's evenly distributing the stresses into the hull side. So the easiest way to make a template for cutting my fiberglass cloth is to take some 3 to 5 mil plastic sheeting that I can tape over top of the area that I beveled, so I can outline where the hole was and then my 4.5 inches out, so I can make sure that the glass is consecutively smaller. So now that I have my template laid out and it's 4.5 inches from the hole, and I know that I need 10 layers, and that's actually 9 spaces, so if I take 4.5 divided by 9, that's a 1/2 inch space per layer. Seeing that this is a perfect circle, I can use a compass, and I just attached a fine tip Sharpie to it, so it's easy to lay out my circles onto this template. We want to make sure that we have a witness mark, so that everything gets lined up in the same position. Seeing that this is a perfect circle, I can put the witness mark pretty much at 0. So every time I come in and I install my layers, I'll just make sure that the witness mark is lined up to the area, because when you do a repair, it may not be just a circular pattern. It may be an oval or a lot larger area. So now we can take our template over to our fiberglass cloth and actually cut to our lines and cut from one layer, the largest layer, to the smallest. You just want to keep in mind that as you cut the area out, you want to avoid sharp corners. Oh, that just creates a lot of stress. You just want to round out the areas for your repair. So I'm cutting the template down a 1/2 inch each time that I'm marking my layers. Seeing that I'm using biaxial glass, so the glass is running on a bias, so it's a plus or minus 45-degree angle with stitching that stitches the mat to the back side. I'm rotating my pattern on top of the glass so the fibers are in all different directions. Because a lot of times fiberglass boats are built around overall stiffness, not so much strength. So if I orient the glass and keep those in multiple different directions, you're going to provide a lot of strength. And a lot of boats, like I mentioned, are built around stiffness, so I do want to mimic the original thickness of the laminate. I am wearing gloves while I cut the glass because I don't want to potentially contaminate the glass too, so it's always a good idea to have gloves on while you're handling the glass. Gloves protect you from fiberglass dust. Each layer I'm marking a witness mark to make sure it goes on the direction that I want it to go on, that you're not guessing how to apply it. And each layer I label to make sure I know what layer I'm on. I just use L5 for layer number 5. So before we start mixing epoxy, we do have a 1-inch hole the glass is going to want to push through, so we need to make a temporary backer. One good option is actually take a flexible spreader. I took some thin plastic and wrapped it around because the epoxy is not going to bond to it. And the advantage to the spreader, it's rigid enough that you can push against it and it's going to stay into position, and it's flexible enough to take the shape of the hull side, and I can tape it into position, and that's going to seal the area off. For areas that are larger than about 1 inch, one good option is actually making yourself a panel with a couple layers, about 6-ounce fiberglass cloth. And this creates a nice flexible panel that for a larger area, you can go in and glue it in. And it is flexible enough that, say if you don't have access to one side and you're working all from one side, maybe the outside of the hull, you can actually flex it and get it through the hull and glue it on, and now you create yourself a backer that the glass can lay against. So now I'm ready to actually wet out the fiberglass cloth and install it onto the hull. So what I'm going to use is our 105 resin with the 206 slow hardener to give myself more working time. I'm going to brush on a light coat. I have my bristle brush here that I cut the bristles down so it's a little stiffer, so it's easier to spread the epoxy on the area. I'm going to actually pour it out into my roller tray, and this is going to increase surface area for the epoxy, so I'll have more time to work with it. So I'm going to brush a light coat of epoxy on the surface. You don't want to put a lot of epoxy on, because when you start wetting out the cloth, you don't want the cloth to start sliding away from the area. I'm ready to wet out my fiberglass cloth. I'm going to start with the largest layer, working to the smallest. So if I were to grind this area smooth, I'd be grinding into the smallest layer instead of the largest, so I get a very strong, reliable repair. I have a witness mark here, so I'm going to line it up with my witness mark and take my spreader and spread it on so I remove any entrapped air. So as I'm wetting out my repair, I want to make sure that the cloth is fully saturated, but I'm not putting too much epoxy on, or it may want to potentially run. Or the patches are going to want to slide because you're fighting gravity. You want to thoroughly wet out the cloth, but you don't want to oversaturate it. So with this serrated roller, the advantage of this is it's going to make sure those layers are staying compacted and that you're working out any potential air between the layers. So what I'm doing is I'm like starting from the center and I'm rolling to the outside, kind of forcing that patch thoroughly onto the surface. One thing you can do too is if you find out that you're putting your layer of fiberglass on here and it's not wet out and it's potentially wanting to fall, you can actually peel back the layer and wet it out and then stick it back on there, and then that helps hold it into position. So that's going to be very helpful. So one thing that you will notice with this patch is you want to make sure that there's not any white spots, but it's not super shiny, because if it is shiny, that's just excess epoxy that's going to want to kind of sag on you and run over time. So you want to make sure it's thoroughly wet out here and it makes good contact and it kind of stays where you put it. The bristle brush helps to kind of dab it too if you find areas that are not completely wet out. See, I got a decent wet coat on the area with the matte side. So I'm going to put this on here and roll it on and thoroughly wet it out. So now that I have all my layers thoroughly wet out, now I'm ready for my release fabric. The release fabric is going to provide a nice textured surface. So if it forms any amine blush, that gets pulled away from the release fabric. So it's ready for more epoxy, or if you're going to paint it, you can put paint right over top of it, the surface. I'm going to put some tape on it to help hold the dry areas up so it doesn't want to sag and fall. And then I just work the release fabric onto the surface with the spreader to make good contact with my patch. And if you have to, well, if you put just a little epoxy on your brush and just spread it on here, it's going to help kind of hold the release fabric into position. The release fabric does not need to be thoroughly wet out with epoxy, just enough epoxy on there to help hold it on there and try to work the wrinkles out. So that's really all you're looking to do, is get all the wrinkles out. The release fabric's making good contact with your patch. We're gonna wait till tomorrow when the epoxy's cured, then we can pull it away and remove it. Say if you're working in a difficult area like the bow, what you can do is actually take a workbench like a horizontal surface and wet out each layer, working from the largest to the smallest. So now I can take my entire patch and install it all in one application. The top of our laminate stack will end up being the exposed side of the repair. We're going to put release fabric over the top to help support the laminate as we transfer it to the hull. The release fabric also helps minimize the movement of the individual layers as they are compressed against the hull. Again, we want to get out any wrinkles and make sure it makes good contact with the surface. So with the release fabric, you just kind of pull it and work it so you work out any wrinkles. And just come back with the brush and just kind of make sure it makes good contact with the surface. So now that I have the release fabric over top of my patch, I'm going to take another piece of plastic and put it right on top of here. I'm going to pick up my patch and I'm going to flip it back over, because I want to put my largest patch onto the surface. So I'll take my plastic film and I'll come back and I'll peel the film back away. I'm going to pick it up and I'm going to line up my witness mark and put it right where it needs to be applied. So now I'll come back with a plastic spreader and work from the center, working my way out to the outside edge. You want to make sure you don't have any air pockets. You want to make sure that that glass makes good contact with that fiberglass. So I'm going to just kind of put good pressure down at a low angle and just force it to the outside edge. And you may hear it pop a little bit, and that's just air working its way out to the outside edge. So now that I have it tacked in place with a spreader, I'm going to use the roller to make sure it makes good contact with the surface. So I'll start from the center and kind of work out to the outside edges. So now that's all on there. We just wait for it to cure till tomorrow, then the release fabric can be pulled away. Now that we waited till the next day and the epoxy's cured properly, I'm going to pull the release fabric and we can take a look at how the repair turned out. So now that I removed the release fabric and the patch is fair to the inside of the hull and it's thoroughly wet out, I'm going to step outside the hull now and remove my temporary backer, and I'm going to fair that repair to the hull side. So I'm going to peel the tape away and we can take a look at how it turned out. I can come in here and I can sand the cured epoxy with some 80 grit sandpaper to dull the surface. Then I'll remove the sanding dust. I can just wipe it away, and from there I'll mix a batch of 105 resin with the 206 slow hardener and just brush on a light coat onto the surface. Then mix a little bit of 407 low density into it. And then I'll take my spreader and I'll spread it on here so it fills in any low spots. I'll let that cure, then I can come back and sand it fair to the hull side. So I'm taking my sandpaper and I'm working it all the way around the outside edge, and this little sanding block, it's flexible enough to be conformable to get into those low areas. Now I can actually take my sandpaper off and I'll fold it back on itself. Now I can take my finger and actually work it into to the inside here and kind of work to the areas that are going to be a little bit more difficult to get to. Now that I have my epoxy mixed up, I'm going to brush on a very light coat because I don't want to put it on too heavy, or my thickened epoxy is going to want to sag over time. So I'll just brush on a little light coat. So now I'm going to add some 407 low density fairing filler into it, and what that's going to do is it's going to make the epoxy a lot easier for me to sand once it's cured. So I want to make sure I add enough filler into it to make it so it's like a non-sag consistency, so when I actually lift my mixing stick, that it hangs on the mixing stick and it just doesn't slide off, because you're kind of fighting gravity here. It's on a vertical surface, so you want to actually make sure it stays where you apply it. As I'm applying thickened epoxy to the area, I'm looking to put it on a little bit heavier to try to make it a little proud of the surface, so when I sand it, I can sand it in fair to the hull side. I don't want to actually take my spreader and use a lot of force and pull it over, because that will actually dish it out and it will be low. This is a perfect time to come back with some paper towel and solvent with some acetone on it, or it could be like denatured alcohol while the epoxy's still uncured. A good time to clean it up. Then we'll just let this cure, then I can come back and sand it fair to the hull side. Now that I've waited a day for the epoxy to cure properly, before I sand the surface dull, I'm going to actually take water and a Scotch-Brite pad to the surface, because seeing that the epoxy is exposed to the atmosphere here, it can leave what's called an amine blush, kind of a waxy film, and that is water soluble. So I'll remove that before I sand the surface dull. So I'll take a clean part of the paper towel and apply some water to it. Before I sand the surface, I'm actually going to take a razor blade, a sharp razor blade, and use it as a scraper, and that will help me knock down any high spots before I go in to sand the surface. You could use a cabinet scraper instead if you had one of those handy. So seeing that this is very sharp, you always want to have two hands on it, on the blade. And what you can see is that as I'm scraping it, it's hitting the high spots here, and you just pull it, and that sharp edge of the blade just scrapes the epoxy off in layers. So as I work it, I'm going to work it like on an X pattern, going about 45 degrees, negative 45 degrees, and kind of work it so I'm cutting the surface cleanly, that I'm not creating a low spot, I'm just hitting all the high spots from the blade. So now that we have the area scraped down pretty good, I'm going to actually switch into sanding it. So I have my little sanding block here that I'm going to start out with 80 grit sandpaper, and I'm going to do the same method where I'm just kind of working it back and forth, and that's going to actually start to remove anything that's kind of proud of the surface to keep it fair to the hull side. One thing that's nice about this sanding block, it's actually flexible enough because the hull side here is not completely flat. You want to make sure your sanding block stays, it keeps the shape of the hull, that you're not sanding it and creating a flat spot on the hull. So when I hold the sanding block, I'm making sure it makes good contact on the back side and front side of the block as I'm working it. So now I'm going to take my sandpaper off and I'll switch to a finer grit. So now with the repair area sanded fair to the hull side, I'm going to mix up some unthickened epoxy and add a little 501 white pigment. So the advantage of applying unthickened epoxy with the 501 pigment will help hide the repair area and provide a uniform base for a UV stable top coat. So you definitely want to remove the tape before the epoxy cures, because it will actually bond to the tape while it's still liquid. Pull the tape away, and now we'll just let this cure for a day. Then I'll come back with water and a Scotch-Brite pad to remove any amine blush and dry it. Then I can sand it dull. Then it's ready for the UV staple top coat. So this pretty much wraps up our repair today. This was a 1-inch diameter hole, so it was small for our sink drain, but you can still use the same process for a larger hole. But if you do have any questions, please reach out to our technical staff or visit our website at westsystem.com. Thank you for watching.